Now we will start a conversation about polynomial functions. Now, polynomial functions are something that you probably have dealt with before, but we are going to take a more in-depth look. So first off, what is a polynomial function? A polynomial function is any function that can be written in this form, where n is a whole number, so that means 0, 1, 2, so on and so forth. And whenever we look at those exponents, the largest exponent, in this case n, is called the degree of the polynomial. The coefficients of our variable are real numbers, and the leading coefficient is simply the coefficient of the term with the highest power. And so this leading coefficient cannot be 0. And then the term that has no variable is called our constant term. And then whenever we write it in descending order, that is called the standard form of the polynomial. Now, because our exponents have to be whole numbers, what you're going to see is that our exponent can never be negative, so we will never see our variable in the denominator. Likewise, x cannot have a fractional exponent, and so therefore we cannot see x under a radical. Let's take a look at an example. Here we have a function. The question is whether or not it's a polynomial. And if it is, we need to write it in standard form, state the degree, and identify the leading and constant terms. So let's first notice that this is a polynomial. Let's go ahead and then write it in standard form. So that means in this case it's just writing it in descending order. So 7x to the 9th plus 3x squared plus 2. And what we're looking at here are the exponents on our variables. So now, what's the degree? The degree is simply the highest exponent we see whenever it's written in standard form. So the degree is 9. What's the leading term? The leading term is that term with the highest degree. So 7x to the 9th is the leading term. And what's the constant term? The constant term is the term without a variable. Now let's look at another example. Is this a polynomial function? Notice that we see a variable in the denominator, and so therefore this is not a polynomial function, and it comes down to this term. So if we think about it, this would be 3 minus 4x to the negative third. So this is not a polynomial function. And we would say there is a variable in the denominator. Actually, we would say in a denominator. Is this example representative of a polynomial function? And notice here, we have a variable under the radical. So therefore, this is not a polynomial function. And the reason being is because x is under a radical. Now moving to our final example of this type, is this a polynomial function? Now, what we do not see is a variable in the denominator, and we do not see a variable under a radical. No fractional exponents, no negative exponents, so there's a good chance that this is a polynomial function. But let's go ahead and multiply it out, and that might be helpful. So let's go ahead and multiply out this negative 3x minus 1 quantity squared first. So that would be negative 2x cubed, and then we could FOIL out the 3x minus 1 times 3x minus 1. And now we can distribute the negative 2x cubed throughout. Remember that as we multiply, we will add the exponents. So we have negative 18 x to the 5th plus 12x to the 4th minus 2x cubed. And this is all times x squared plus 4. Now let's multiply this by x squared plus 4. So we have the negative 18x to the 5th will get multiplied times each one of these two terms. And this gives us negative 18 x to the 7th minus 72 x to the 5th. Then we have 12x to the 4th times each one of those two terms. And so that will give us plus 12 x to the 6th plus 48 x to the 4th. And then lastly, we have negative 2x to the 3rd times each one of those. So we have negative 2x to the 5th minus 8x cubed. Now let's collect like terms and write in descending order. So we have negative 18x to the 7th. Now do we have any x to the 6th terms? And we do. We have a plus 12x to the 6th. Then our x to the 5th will be negative 74 x to the 5th plus 48x to the 4th minus 8x cubed. So this is a polynomial function, and we can identify the key properties. So this is a polynomial function. The degree is 7. The leading term is negative 18 x to the 7th. The constant term is 0.